Thank you. I was not keeping well. Guys, this lockdown and work from home kind of arrangement, right? So I have to leave my office early and um, take the classes from my house. Anyway, I think it's getting better now. Shall we begin? I see still very few people have joined today. I don't know why that's the case. What do we do? Shall we wait? What do you say, guys? Because the population is very, very low, right? 2 minutes wait. Okay. What we'll do is we'll wait for 2 minutes. And what meanwhile we can do probably is we can just quickly revise what we had done yesterday. Sure? Okay, great. So very quickly, and now I'll turn off my video because low bandwidth at home, right? Not in office settings. Just want to say hi to you guys after a long time. Cool. So this is what we discussed. We first finished with the classes inheritance using the extends keyword, right? And we realize it's working exactly same as the prototypal version of it or the functional version of it, right? So two things we learned: extends keyword and super. What does super do? It basically calls the constructor of this guy with the this of the present class, right? So it's exactly equivalent of animal.call this name energy, right? Done. So that topic was closed. Then we started talking about asynchrony, right? Or asynchronous JavaScript. And there, guys, we realized how JavaScript internally manages tasks, right? And the simplest or smallest example of task is nothing but function, right? So we took a very simple example. And this is after the context of knowing that JavaScript is a single-threaded language, which means at a time, only one thing can be done. So while one function is getting executed, the other cannot, right? So when JavaScript has to execute one function and it ends up taking a lot of time, it's going to block everything else, right? Okay. So then we took a very simple example, two functions, task one and task two, right? And then we understood two important concepts. One is execution context. The other is call stack, right? And this is how we realize internally JavaScript keeps a track of all the tasks that it has to execute and in which order it has to execute and how they work. So how did this happen? First, task two was pushed to a stack, which is a LIFO construct. Task two was pushed, then you started task two. You pushed this guy, then this guy immediately came out because the only execution of this guy is this much. Then task one was pushed. The moment task one was pushed, we went inside it. This guy was pushed, immediately came out, right? And then task one also came out, right? Finally, you pushed this one and this one, then you popped them, and then you popped out task two, right? Any doubts up till this point? No? Okay, cool. Then I basically gave you the example of how this can be taken to a restaurant and a waiter analogy, right? Where a restaurant can have multiple waiters, as in the case of Java, and these waiters are basically workers or threads, whatever you want to call them. And if you have multiple threads or multiple waiters, you can do more work with them. But the only problem is with more workers comes more complexity, because now these workers have to talk amongst themselves. Because if they're not going to talk with each other, what is going to happen, guys? If the workers or threads don't talk to each other, what will happen? अरे कोई तो बोलो. Crash. Okay. Concurrency, corrupt. Okay. Collision, बढ़िया. All good words. Not concurrency, Shivam. Concurrency का मतलब होता है चीजें साथ में होना. Concurrent, right? But the perfect word Ajay used, corruption of data structure, was one example we discussed, right? Because मान लो एक ही आ रहे हैं and there are two workers who are simultaneously working on it. So the result that you may expect at the end of worker one's execution could be drastically different, because worker two भी उसको बार बार access कर रहा था कहीं ना कहीं से, right? So concurrency has great advantages, but it has great disadvantages also if not used properly. And this is one thing which makes JavaScript simple to use, right? while a lot of you will not agree to this, that it's simple to use after you learn Java. But it's easy when you talk about things like parallel programming, multiprocessing, multi-threading, and all those concepts, right? Not very relevant for us at this stage. Okay. Anyway, going forward, we took another example, right? And in this example, guys, what we basically learned, I'll quickly summarize it. So let's say you were making a web app, right? Which was about uploading images, processing those images, posting those images to the social media, internet, whatever, and finally giving you a success message, right? So you are calling these functions one after the other. First, you called resize image, then you called post image, and then you called success image. Now we know that JavaScript only has one call stack, right? And it's single threaded, of course. So these things are going to happen synchronously or one after the other, right? So you call resize image, and let's say it takes a lot of time, right? Because image processing is a complicated task, or it's a tough task. Like we saw yesterday, when we were trying to process an array of 10 to the power 7 elements, there was a significant noticeable delay, right? And during the time when JavaScript single or only thread is busy doing this work, this resizing of image work and everything, that time it's completely blocked, right? It cannot do anything else. So one example I always like to give people, see, now you know everything about DOM and you know about event listeners, right? So we had talked about the click listener here, if you guys remember, right? So guys, what is this? This is a click listener, and what it is doing to JavaScript, basically there is a callback which gets executed, right? And make no mistake, this works exactly on the call stack model, right? Now, in this case, what happens is whenever you do a click, the browser is going to request JavaScript, hey, there a click had happened. Please put this function in your call stack. Did you guys understand what I just said? Now we are relating DOM with JavaScript, right? What about others? Only Shivam understood what I said? Right? What? See, okay, cool. Now we are talking. So here what you are telling the browser, hey browser, whenever there is a click on this button, right? Whenever there is a click, please just push this function to my call stack. This is exactly what JavaScript told the browser. We understand these concepts now, right? But imagine when you were resizing the image, actually, right? When you were doing all of this resizing and someone pressed a click, right? So the browser was able to listen to the event, right? Click event. The browser was also able to push that element to the call stack of JavaScript. But will JavaScript be able to execute it, guys? Will JavaScript be able to execute it? Koi to bolo. No. Why, Amit? Why will JavaScript not be able to execute it? Exactly. Till the time it has not resized the image, right? If there is a click, right? Basically, although you can push it to the call stack, but exactly, Mayank has used a perfect word. So this is an example of blocking code. And whenever the JavaScript main thread stays blocked for a long time, what is going to happen? Bad experience, right? Because you assume you had, please understand this, assumed you had uploaded an image, right? That image was getting processed, right? When that image was getting processed, let's suppose the customer is multiple times clicking, right? Those event listeners will keep getting stacked because we know JavaScript has only one hand, right? While it's doing this, it will be able to do nothing else, right? The experience that you're going to see is you are clicking the button, but nothing is happening, right? And that's why such an arrangement is a problem in JavaScript, right? Such a synchronous arrangement is a problem. Because if there is a huge blocking code, it means JS is not capable of handling it. Did we understand the problem, everyone? Right? So even if it's processing of a huge array, even if it's resizing image, anything which is computationally expensive or which takes a lot of time causes what? Causes bad customer experience. Get this through your head. This is what is going to make you great front-end engineers if you understand this right now. Anything computationally expensive, anything which takes a lot of time to execute, makes the main thread or the JavaScript thread busy, and JS will not be able to do anything else, not even scroll the page. Are we clear? Right? As a good practice, you should always, always, always restrict your functions to 50 milliseconds, right? We'll talk about that in a second. If your functions are taking more than 50 milliseconds, there is a mistake that you've committed. Does anyone know how we can measure time in JavaScript? Do you want to learn? Do you want to learn? If everyone says yes, I'll teach you, because of course it's not in your syllabus. अरे milliseconds तो unit है बाबा, measure कैसे करोगे unisecond? Okay, so we'll do it then. Cool. Okay. Example for you guys. Let's see. Right? So not a very popularly known tool, but we do console.log all the time, right, guys? We do it all the time. There is something called as console.time, right? In which you give a string, which is more popularly known as label. I'm just going to call it time taken, right? And then there is something called as time end, right? And whenever they have the same label, JavaScript is basically going to compute the time of whatever happens in between them. Did you understand? Cool. So if I do nothing and I press enter, what should happen? What should I see? Okay, once again, Mayank sir, simple baat boli. There is a way of computing time using something called as console.time. What does it take? It takes, who did that on my screen? Guys, console.time takes a label or a string, right? Whenever you start that time, whenever you write this, that timer is started. Whenever you say time end, that timer is stopped. Whatever happens in between these two, JavaScript will simply record the time of that, right? So if I'm doing nothing between these two, what should happen when I press enter? What should be the time that I get? 0. Like theoretically, it should be 0. But like Shivam said, it will be some millisecond. Okay, let me do that now. Okay, hitting enter. What did it say? Are you guys able to read this? It's at 0.0019 milliseconds, right? So it's actually in nanoseconds. That's how fast it is, right? Nanoseconds, guys, not seconds. This is 10 to the power minus 3 millisecond kind of stuff, which is nanosecond. This one, not nanosecond, right? Microsecond. My bad. 10 to the power minus 6 is micro, not nano. Nano is 10 power minus 9. Those are CPU speeds. Each time we will get a different value, right? Of course, there will be some different time, right, in executing these things, depending on how busy my CPU is, how much RAM my Zoom class is taking right now. If I was not on this call, maybe something less or whatever, right? Cool. But now, I mean, this is not cool enough. What we want to do is let's say we want to sum up an array, right? And we'll see how summing up arrays of different sizes can have different impact on our time, right? So same code I'm going to use, which I used yesterday, 10 to the power 3 alpha try with dot map el, and I just put el in that, right? So what is this doing? This is creating an array of 10 to the power 3 size, and this guy is basically looping over it. That's what dot map or dot for each. Anything you do is fine. Cool. Do you understand, everyone? And let's see how much time it takes. Okay, I'm going to press enter now. Okay, this guy has some problem with me using new like this. So I'm going to give a space. Okay, it's my setting, is it? right? This works. This works. This works, right? And what was the problem with my code? Okay. Okay. I have no idea what is happening, but this definitely works. And I should be able to put this in a function. Do you guys see a problem? No, but when I'm doing this thing, right? Isn't this the same thing? Is this correct now, everyone? Array, map, and everything. Right? Cool, it works. Right, bracket problem. Right, so how much time does it take to iterate or loop over an array of 1,000 elements? It takes 0.08 milliseconds, right? Let's say we had 10,000 elements, right? Okay, now we are going somewhere. Now it's 0.4 milliseconds, right? Which is approximately a 5 times increase, right? Let's go higher. Let's try 10 to the power 5, which is a million elements in the array, right? And let's see how much time it takes. Whoa, it took 6.6 milliseconds. And if you go to a million operations, right? I'm not crashing my computer, Sunny. No. If I do a million operations, 37 milliseconds, that's still fine. The moment you start venturing into 10 to the power 7 category, or 10 million, right? So what is 10 million, guys? It's 1 crore. When you do that, time starts going up drastically. And it really becomes impractical when you have 100 million entries, right? Right? Let's see this. Still computing, still computing. Finally computed. How much time it took? Did you see? From 169 milliseconds, it has suddenly jumped to 3.8 seconds, like close to 3.8, 3.7, whatever. But a lot of time, right? Again, trying it once. Now 3.8 seconds, correct? So what did we learn? We just learned how can we compute such times in JavaScript, right? I'll just copy this one example for your knowledge. Not really needed. And I'm going to mention it, computing times in JS. Great. So what we have seen above is whenever such a thing is happening, right, guys? So now imagine when you were doing work on a pixel. So what is an image? Image is an array of pixels, RGB values, right? And typically in megapixels, you have 10 to the power 5 or 10 to the power 6 pixels, right? But as the resolution of an image keeps going up, this operation starts taking a lot of time, right? And this operation can take 3, 4, 5 seconds also, right? So imagine you're stuck on a website, waiting for 4 seconds and not even able to click the website, close the Chrome tab, or even scroll. That's horrible customer experience, right? So now does everyone understand the problem that we're trying to deal with? Is the problem clear? Okay, right? Problem is one waiter, too many tables. Not the system, only the tab. Only the Chrome tab, right? Okay, moving forward. So what is the solution? Anyone, what is the solution? Async. Asynchrony is the solution, right? Not doing everything immediately is the solution, right? Okay, Vishal, that's a very valid point. Now let's understand the element of asynchrony here, right? So what is asynchrony? Asynchrony is not doing something immediately, right? Doing something with a delay or doing something afterwards. That's what asynchrony is, right? And I gave you an example of asynchrony yesterday. Actually, I give you 2 examples, right? The first one being set timeout, right? So what does set timeout do? We'll quickly revise this also. When I say set timeout, console.log1, 2000, right? What did we see happened? After 2000 milliseconds or 2 seconds, it is going to log 1, right? Basically, it's going to do this task after this much amount of time, right? Pause is the wrong word, Vishal. Kal bhi samjhaya tha. See, you can't call it pause. Why? Because let's say I'm trying to do this. Which one will get written? Which one will be logged first? Will it be 1 or will it be 2? 2. अब सबको पता है. And why is that happening? Can anyone? अरे प्रतीक भाई, कल ही तो समझाया. प्रतीक, why will it be 1? याद है ना प्रतीक आपको? Or shall I explain it again? बोलो. Okay. Cool. See, now when I press enter, 2 is logged first, and after 2000 milliseconds, 1 is logged, right? So guys, set timeout does not mean that JavaScript is waiting for 2000 milliseconds, right? Rather, what we should say is that we now have a mechanism to execute this function asynchronously, right? Whatever function we provide as the callback of set timeout, it happens asynchronously, right? And on the contrast, if you remember, we have used callback functions extensively now. For each x, console.log x, right? This guy does not happen asynchronously, correct? This guy happens synchronously, and we just saw the example of that, right? So not every callback happens asynchronously, but set timeout takes a callback which is executed asynchronously. That's the only point I'm trying to make. Undefined is coming from console.log, Nagendra. So can we say delay? It is, yeah, of course, right? It's executing this callback with a delay of 2 seconds, right? But not every callback is delayed, or not every callback is asynchronous. This is an example of synchronous. This is an example of asynchronous, right? Pressing enter, synchronous. Guys, are we clear? Okay, now comes the important question. The question is, how is it working, right? We know for a fact that JavaScript is single-threaded, right? So waiting for 2 seconds or stopping the execution or making the language busy for 2 seconds is definitely not an answer, right? It will just screw up everything. It will screw our customer experience, correct? While in other languages like Java or C++, which can be multi-threaded, what you can do is you can create a new thread, literally, that's how easy it is, and you can ask that thread to sleep, right? So there is a way you can say thread.sleep, and the execution for that thread is going to get paused. But in JavaScript, where you just have one thread, you can't do that, right? Because if one thread, there is only one worker, and that worker is not working or is sleeping, what are you going to do? You can't execute anything, right? Then how is this set timeout working is a question that everyone should have. Does anyone have an answer? Shivam has an answer. What is the answer, Shivam? I can unmute you. I want to hear from you. Unmute. Okay, great. Let's hear from Shivam, guys. Go on, Shivam.
Hello.
Hi, Shivam.
Yes, sir. So when we use set timeout,
okay,
in this situation, sir, Java engine or JavaScript compiler. Hello.
Yeah, go on, go on.
Okay. Okay. Does not execute the set time out codes. Means जो हम set time out के अंदर लिखते हैं उसको एग्जीक्यूट ना करके दूसरे कोड्स को एग्जीक्यूट करता है.
ओके
हाँ, ओके. If we specified like 2 seconds, then it will not execute. It will execute after 2 seconds. Meanwhile, he mm, JavaScript compiler execute the other code like console.log something else,
Okay.
and after 2 seconds, he will execute the set timeout codes.
Okay. But Shivam, that still does not answer कि काम कैसे कर रहा है, right? So what you're telling me is basically the behavior, right?
Yes, sir.
But how it is working, do you have an answer for that?
So internally,
Yes.
okay.
Like Sirjul said, Sirjul, I think, raised a very good question here, but it's single thread, not multi-thread, right? So who
Yes.
is going to execute this? अगर JavaScript thread आगे बढ़ गया, right?
Okay.
Guys, one thing let's be very clear of. Shivam, आप unmute पे रहना भी. Let's
Okay.
say
Okay.
I'm writing all of these things like here, right? And let's
Okay.
say there were 1,000 of them, right? There were 1,000 console.logs, right?
Okay, sir.
Then everyone try to answer this. Are all of those 1,000 console.logs going to get printed? Right? What if it takes more than 2 seconds? इतने सारे हमने console.log लिख दिए. Or rather, let's just take the example which we talked about. Okay, please try to answer this, everyone. If I write सब हटा, सब भूल जाओ. If I do this here,
Okay.
okay, I see here. Now, everyone, please try to answer this question. Everyone, focus. How much time does it take? We all just learned. कितना time लगता है शिवम इसमें?
लगभग 4 सेकेंड.
लगभग 4
Yeah,
seconds. So
approximately.
it takes 4
Yes.
seconds. Let's assume that, right?
Yeah.
So if this guy is going to take 4 seconds, क्या फिर भी 2 seconds बाद 1 लिखा आएगा या नहीं? I want everyone to answer this. शिवम, पहले आप आंसर करो, आप कॉल पे हो.
Okay, sir. Okay, sir. Okay. Sir, according to me.
Okay. The question is simple. We know that this guy takes 4 seconds, right?
Yes.
तो क्या हाई पहले लिखा आएगा या 1 पहले लिखा आएगा is my question. Everyone, हाई first
Okay.
or 1 first? Please chat पे लिख दो सब लोग. Either write 1 or write high. शिवम, आप आंसर दो फिर.
Okay, sir. Okay. Sir, first one आएगा.
First 1 आएगा. Okay. ऐसा क्यों? Why do you say that?
सर सपोज ये एरे को रिवर्स करेगा सर जैसे ही 2 सेकेंड होंगे मीनवाइल आई थिंक ये इस स्विच कर जाएगा.
Okay. So आपका आंसर है
and
1.
then yeah.
Okay. ठीक है.
And
And why is that? आप ऐसे क्यों बोल रहे हो 1 आएगा जब ये 4 सेकंड लेने वाला है? तो क्या
Okay.
ऐसा होगा शिवम जब हम okay guys, now think of it this way. Everyone, I want you to think again. आरवी सुनो पहले. इसको टाइम जब आपने ये एग्जीक्यूट कर दिया, राइट? उसके बाद
Okay.
दिस गाइस इसको एग्जीक्यूट होने में कितना टाइम लगता है? 4 सेकंड लगता है, राइट? सो
Yes,
व्हेन
sir.
आई एम ट्रैवलिंग दिस, तो क्या मैं बीच में ट्रैवल को रोक के 1 प्रिंट करूंगा? ऐसा होगा क्या गाइस? See, one thing we have established, JS is single threaded, correct?
Yes, sir.
So when I am traversing this guy,
Yeah.
right, 2 seconds will definitely get elapsed. तो उसका तो टाइम हो गया 1 लिखने का.
Yes,
Yes
sir.
or no?
Yeah.
Right? So does it mean मैं array को traverse करते करते बीच में I'll stop and I'll print 1? Everyone think? Nope.
No.
If that is not the case, then do you guys want to change your answer? 1 पहले आएगा या high पहले आएगा? Okay, Ajay says, sir, but at start, if it runs 1 up first and then go to high. Pratik, there is no understanding here, Baba. With that, and if I run this, that will give you an answer. Where will the understanding come from? Guys, focus. The question is, if this guy is going to take 4 seconds, right? And we are saying that after 2 seconds, 1 was definitely going to get printed, right? So I executed this, then I start executing this, right? It takes 4 seconds. But during
Yes.
those 4 seconds, we are absolutely sure that this time is going to get elapsed. Because इसमें तो 3 seconds लगना था, right?
Yes.
Right? So Shivam, just want to hear from you.
So, okay.
There is no wrong answer. You guys don't know the answer, so that's fine. I just want you guys to think. That's why I'm spending time on this, right? सोच के बोलो आपको क्या लगता है? Okay, Ajay has given a very logical answer. Okay, anyway, let me explain this. By the way, the answer is not what you think. The answer is the opposite of it. Let me show you. Why does this happen whenever I do this? Please wait. Hi and 1. Okay. So without a doubt, we have established that hi is going to come first and then 1 is going to come. Okay. Now we have to understand this trend. Right? Amit, syntax छोड़ो, अभी important things है. Yes, the why is what I'm here for, right? Okay. See, and for this, today I'm going to draw. Just check. वही बता रहा हूँ, रुको तो sir. Okay. We know that JS has a call stack. Right? Very bad drawing. JS has a call stack, right? So let's understand everything from call stack point of view, right? So पहले क्या लिखा था? There was a set timeout written, right? So what should happen is set timeout should get placed first, correct? Right, guys? Right? So I'm just going to denote this by SP because it's set timeout, right? Then what happens? There is an array function. There is an array mapping, a big function, right? So I'll represent it by A because it's an array, right? And finally, there was, it's very hard to draw here. There was a console.log, which is saying hi. So I'll present it by hi, right? So we had set timeout, we had array, and we had hi, right? So in conventional sense, whenever you're pushing these things, right, they should get executed one after the other. But guys, the only problem with that logic is set timeout, right? After how much time should it get executed? The set timeout callback should get executed after 2 seconds, right? But if I wait for 2 seconds, then what is the problem? If I wait for 2 seconds, then I will not be able to do anything that comes my way, isn't it? Because I'm blocked, right? And if I started to get blocked for timers, right, what am I going to achieve? Right? So what we need to understand after this logic is that set timeout must be behaving very differently. That is something that we have to establish for a fact, right? Is that a logical confusion, everyone? कि set timeout के साथ कुछ off है. It does not behave the way we think it does. Okay, so then how the hell does it behave? Is the question we are trying to understand, right? And that's what I'm here to tell you, right? So while JavaScript just has one call stack, right? There is also the browser which is running, right? And browser is free of those limitations. Browser can be multi-threaded. It's written in C++. We know that. The V8 engine is written in C++. So it can be multi-threaded, right? I'm just going to represent this by B or the browser, right? So here is what I'm going to tell you. Set timeout is not a JavaScript API, right? Or again, let me repeat myself. Set timeout is not a JavaScript function. Then whose function is it? It's a browser's function, right? Guys, whenever we say in JavaScript document, right? Or basically we select an element and say .add event listener, right? Whose function is document? Document is given by the browser, right? Because it's the browser which understands DOM, right? And similarly, set timeout is also provided by the browser. Did you guys understand what I said? Right? Once again, okay. See, what I'm saying is, just like you had document dot get element by ID, document dot query selector, and we had multiple things, right, related to document. They are not the things which are coming, which are shipped with JavaScript out of the box. They are the things with which the browser is providing to JavaScript, right? So in a way, what are those? Those are browser APIs, right? And what is JavaScript just doing? It's just requesting the browser. So when you say set timeout with a callback, in some sense, JavaScript, you know what JavaScript is doing? It's telling the browser, hey, I'm giving you this callback, right, which I want you to execute, saying console.log 1. And I want you to call this after 2000 milliseconds. Did you understand what I just said, guys? Did everyone understand? Mayank, क्या नहीं समझ आया exactly पूछो, because it's a complex topic. Which part, Mayank, if you can, feel free to come on unmute if you want that. Okay, last part. So instance and delegates the job to the browser, if I may say so. Okay, let me explain from the very start, since there are some questions, right? Okay, so what I'm saying is, if JavaScript had to wait for 2 seconds, that cannot work. We have established that. Why it cannot work? Very simply, because if JavaScript was going to wait for 2 seconds, then what else is it going to do? It's a single threaded language. At a time, it can only do one thing, right? So if it's blocked for 2 seconds, then for 2 seconds, nothing else can happen. No scrolling, no clicking, nothing, right? So what happens is the environment in which JavaScript runs, right? The environment in this case is the browser. So browser gives you a lot of APIs or a lot of functionalities, if I should say so, using which you can take browser self, right? So we've talked about earlier document.add event listener, document.get element by ID, right? These were not inherently things which were native to JavaScript or which belong to JavaScript, right? These are things which the browser is helping us with. So the browser is saying, hey, whenever you want to access this particular HTML div, you can use my document API, right? Or you can use my document.whatever feature. Similarly, it's the browser only which is giving us this set timeout capability. So when we say set timeout, right, and we give it a callback, in some sense, we are actually requesting the browser that, hey browser, after 2000 seconds, please execute my callback. And in this callback, what are we doing? We are simply saying console.log 1. Does that make sense to everyone? Make sense to everyone? Mayank, ab clear hai? Okay. Now let's understand. Now let's dig a little deeper into it, right? So guys, essentially there is a communication between the JavaScript runtime, or where the JavaScript is running, and the browser, right? Right? And of course, it's not just one time that JavaScript could have called set timeout. You can have a list of 100 set timeouts also, right? And whose responsibility is it to maintain those timers? The responsibility lies to the browser. The responsibility is of the browser, right? Okay. So how does it work internally? Now we are going to spend some time understanding that. Right? So these guys, these things, right? The browser APIs are not part of the actual JavaScript. So how does it work? This API is new. What is the API you mentioned? No, I just said API is also another name for functionality, right? set timeout is a browser API. What that means is set timeout is a browser functionality. अरे भाई क्या बोल रहे हो मयंक, डेटा करप्ट कैसे होगा? ब्राउजर को क्या पता डेटा के बारे में? ब्राउजर को आप set timeout, when I say set timeout is a browser API, it basically means that the responsibility of calling JavaScript's callback, right? What is callback? This function is of the browser. And how much time should it call back after 2000 milliseconds? Shweta, hang on, I'll read that message now. Can you paste it again? The question. Shweta, paste it again, please. So which means a timer thread in the browser starts counting down, and when time is up, puts the callback function in JS threads execution stack. Thus, callback function is not executed before the function above it in stack. There could not be a better explanation than what you've just explained, Sweta. Perfect. Love it. Absolutely. Guys, you should read what she's written. No, now I will also explain. Don't worry. So it is not that JS is delegating jobs with condition to browser whenever there is a set timeout call. Like, so no, let me tell. Ruk jao. Now see, Sweta has already done it. Now let me give the answer. Right. So how does this work? Right. So whenever the browser sees set timeout, what it is going to do, guys, it's going to request the browser, right? So there was a set timeout. JavaScript is going to request the browser, right? Right. With that, hey, you call me back after 2 seconds. 2 seconds. Right. Cool. Now, what is the responsibility of the browser? The browser will not be capable of writing directly to JavaScript stack, right? The browser at max, what can it do is, suppose guys, there were 10 set timeouts, right? With JavaScript executed one after the other, right? So right now I'm writing here one. What if I mentioned 10 set timeouts after this? So one, this, another, and I wrote 10 set timeouts. JavaScript is going to request the browser with all of those set timeouts, right? And then what, guys, if there is one more thing on the chat right now, I'm going to block the chat for the rest of the class. Can you please listen? Please stop writing on the chat. This is the last warning. Okay. Whenever JavaScript calls a browser API, right? Or JavaScript wants to use the browser functionality, let's say set timeout. Let's say there were 10 set timeouts that we had written here, right? For each of those set timeouts, JavaScript is going to request the browser, right? Now, please understand one thing, absolutely clear, that whenever something needs to be executed by JavaScript, it needs to be in the call stack. There is no other way that JavaScript can run or execute that function, right? So let's say JavaScript, basically when we wrote set timeout here, JavaScript is going to create that entry in the browser, right? What the browser is going to do after those many seconds, after 2000 seconds, there is a queue here, right? And what is queue, guys? Unlike stack, queue is FIFO. What does FIFO mean? First in, first out, right? When those 2 seconds have passed, right? What will the browser do? It will just move that callback to this queue, right? And what is this queue called? This queue is called messaging queue or MQ, right? So the callback function, which was saying console.log1, is now going to get placed here, right? And represent this by 1. So I'll write 1 here, and I'm going to write 1 here. Cool. Now, whenever JavaScript's call stack is empty, right? And when will it be empty in our case? Please look at this very carefully. When line number 1604 has executed and line number 1605 has executed, right? Then JavaScript does not have any task, correct? It's only then that this guy, one, is going to make its way to the call stack, right? And once it makes its way to the call stack, basically this function, this callback function, which says console.log1, that's when we are going to see 1 on our console. That's where I stop. Please ask your questions now. Yes, please ask as many questions now. Explanation is over. By the way, guys, did everyone understand? Feel free to write on chat now. Yes, I'll just come to that case, Ankit. Perfect. Rabia, what you've mentioned is absolutely, it really marks a good understanding. So see, this is one of the things that I would ask in an interview, right? I'm going to say that, hey, when I say 2000 milliseconds, is it a guarantee that after 2000 milliseconds is going to get executed? And Rabia has given that answer. Do we all understand this? It's not necessary that it will, there is no guarantee for it to get executed in 2000 milliseconds, right? Because it can only execute when the call stack, it's basically a mathematical equation, right? Less than the time it takes for the call stack to get empty versus the time actually that we have allocated, right? So the time we have allocated is 2000 milliseconds, but let's say it takes JavaScript call stack to get empty. The time it takes is 10 seconds, right? So when are we going to execute this? After 10 seconds plus. Because although until that time, the thing or that callback is just going to lie in the messaging queue. This is the pure concept. Questions, guys, questions. Guys, ask questions. Otherwise, I'll have to assume you understood it too well. Okay, I mean, this is coming as a shock because event loop is one of the, so by the way, this concept is called event loop. What is it called? Event loop, right? Text, and let me write that here, event loop. Okay, Ankit has a question, sir. Suppose that there are some function in timeout which needs to be executed. What will happen then? Ankit, this was a function which was executed, right? Console.log1, this is a function which was executed. And what happened to it? It first moved to the browser. When browser had passed those 2000 milliseconds, it moved it to the messaging queue, right? Whenever JavaScript was free, JavaScript read from the messaging queue and executed it. And this whole loop of JavaScript talking with its runtime, JavaScript talking with its environment. The environment in this case is browser. So what is browser? Browser is a JavaScript runtime or a browser JavaScript environment. Is called the event loop. Okay, one by one. So this MQ is only for browsers. JS or JS engine also say before loading up in the stack. This is an agreement between JavaScript and its environment, Amit. So JavaScript can only be considered loaded once the messaging queue is ready. Suppose array taking 4 seconds, then set timeout will take 4 plus 2 seconds. Yes, Shivam. But suppose that timeout event is needed to execute next stacked function. Please give an example of that. What you're saying is hypothetical, Ankit. Sweta, what was your question? Can you type it out again? It's just scrolled up. Yes, Ankit, I'll unmute you in 1 minute after I answer these questions. Simple. When and only call stack will get empty, then the things will get pushed from MQ and that executes. So after that time execution will happen. That depends on call stack to get empty, not on what set time we have provided, right, sir? So like I said, Shweta, it's going to be a mathematical equation. It's going to be the maximum of those two. So essentially you need two things to execute, right? First thing you need is for that much time to have elapsed. Condition number one. Second condition is the call stack needs to be empty so that it can read from the messaging queue. Sure. Callback executed on browser or call stack. Callback, see, callback is this JavaScript, Pradeep, that we've written, console.log 1, is it JavaScript language? So where the only place where a JavaScript function can be executed is where? Where would that be, Prateek? Call stack, right? So does that answer your question? Browser is not a JavaScript runtime, guys. JavaScript functions only get executed on JavaScript. I'm going to unmute Ankit now. Go ahead, Ankit.
Hello, sir. Am I audible?
Perfectly, yaar. Bolo.
Sir, my question was, as you said, the messaging queue will be read after the call stack
is empty.
events, all the call stack events were executed.
Yes.
But suppose I have multiple functions.
Okay.
And among them, there are some timed out functions which will be executed after a certain time.
Sure.
But after this timed out function, there is some function in the call stack which is needed that timed out function to be executed first.
Okay.
So in that case, what will happen? Will that messaging queue push that
no, absolutely not. So just be unmute only, right? Because it might take discussion. So the way it's going to work is always this, right? Basic concept. Whenever JavaScript sees, let's say, a set timeout, it's going to move it to the browser, right? It's going to say, hey, browser, you call this callback function, this guy, after these many milliseconds, right? Whenever these many milliseconds elapse, the browser is going to move that task, right? Or that basically that callback to the messaging queue, right? So messaging queue, what does a messaging queue hold? It will always be JavaScript callbacks, correct? Ankit, are you there?
Yes.
Right. So neither JavaScript nor the browser care about what is the time written here, right? The concept is basically this. After so much time has elapsed, I'm going to move it to the messaging queue. JavaScript, whenever you are free, please read from your messaging queue, right? Because what does a queue mean? A queue means that people are standing in line, right? Just imagine it like this. There are so again, let's go to the waiter analogy, right? So what the kitchen is now saying that, hey, I have 30 items ready, right? 30 tables ka food is ready in me, right? Whenever JavaScript is free from taking orders and all those things, what it's going to do is it will take the first item which got ready, right? So let's say there is a table and the kitchen is just keeping things in there. So whatever the kitchen has kept first, it means that that was of highest priority, right? Then it will just take that, push it into its call stack, execute it, move to the next one.
Sir, I'm not saying that. Suppose there are 10 functions. Among them, there is a function on line 4, which is timed out. Then it is moved to the browser and it will be moved to the messaging queue after that set time.
Cool. Okay.
Then there is another function on line 8, which need that output of the function of line 4, which is timed out.
Okay.
And is in messaging queue right now.
Okay.
But then what happened in that time? is that messaging queue, will the JavaScript read that message queue to get that
No, absolutely
function?
not.
Yeah,
No, like I said, Ankit, the JavaScript, I try to answer the same thing only.
that means the JavaScript will stop working.
No, how can a language stop working, buddy? It's how you write your code, right? If what you are saying is, I need to wait for this guy's result, that's what you're saying, right?
Yeah.
When you're saying set timeout, what does set timeout means? That you want to execute this action after certain time, right?
Yes.
First question is, if you wanted this guy's result immediately to execute this line, right? Right? That's what you're saying? Then why
Yeah.
will you put it in set timeout? Can you think of one use case where this could be the case? If you want this guy's result to be used on the next line, then why will you put it in set timeout? And if you really want to perform that action for after these many seconds, whatever, then you're going to move this line here, right? Inside the set timeout that, hey, after this thing has elapsed, you execute this function, then you perform whatever thing you needed from that function, right?
Okay.
In set timeout, of course, you can have multiple function calls, right? So there could be task one like this, and there could be a task two, which requires the input of task one. Result is equal to task one, and then you pass that result to task two. This is what you are talking about, isn't it?
Yeah.
So this whole becomes a callback for set timeout then, right?
Okay.
Is your question answered?
Yeah.
Okay, great. Guys, any other questions that you have? Is MQ a part of JS or browser? Nagendra, MQ, like I said, MQ is messaging queue is basically an arrangement between or a contract between the browser and JavaScript, right? So it's not a part, neither a messaging queue nor browser are a part of, neither the browser the browser scope are a part of JavaScript language. The only part of JavaScript are two, what we have talked about. One is the execution context, the other is call stack, and nothing else. Everyone clear? Guys, yes or no? Amit sir, clear hai? Okay. Consider there is one exam for 60 minutes, and then after that, student will get one mail like attended exam successfully in such case. Okay, fair enough. Guys, timeout first gives output. Okay. Okay, Ajay. I'm not sure where you're getting with this, but yeah, what you're saying is right. Guys, one request. You guys might want to take a screenshot of this because I'm going to erase this then, right? So just I'll just take a minute and take a screenshot of your screen if you require so. Done? Have you guys taken a screenshot of this diagram? Okay, done. So I'm going to remove this now. Perfect. Smart people already took it. Okay, clearing this. Oh, I have an option to save this, and then probably I can send this also to you guys. Not sure how that works. Let me send it to you also on this chat. All my drawings. Okay, Siddiq has beaten me to the race. Great, Siddiq. Shall we move forward then? Sir, how it's understanding our code if there is only execution context and call stack. See, when you say understanding our code, who are you talking about? Are you talking about the browser or are you talking about the JavaScript? Can I unmute you, Pradeep? Can you explain it to me? Okay. Go ahead, Pradeep.
Yes.
Hello.
Good evening, sir.
Good evening, Pradeep.
So I'm a little bit confused, but my question is like how it's understanding the data types and functionality. It has only a call and execution of context and not any other information about variables and other things.
Who has?
I've this engine, JavaScript engine or browser.
No, a browser is not the JavaScript engine, right? So, okay, understand this. Like, damn, I should not have removed that. Okay, anyway, there are two elements, right? One is the JavaScript stack, call stack, right? In which you put tasks or you put functions and those functions are executed, correct?
Yes.
Right. Now the browser, see, when I say set timeout and I provide this callback, right? Does the browser need to know what is inside it, Pradeep?
No, sir.
No, the only thing that the browser needs to know is basically a reference to it, right? All the browser needs a reference to this, right? So think of it like this: the browser is going to maintain a reference or a link to it, right? Now, whenever these many milliseconds have elapsed, what the browser does is it moves that reference to the messaging queue, correct?
Yes.
And whenever JavaScript is free, it's going to translate that reference into this actual function and then execute.
No, sir. I understood the event loop. I'm asking about the call stack and these execution and context, how they work on the engine.
Okay, so you want to know how? So essentially, what you're asking me is how JavaScript works.
Yes, sir, on this engine.
Sure. See, what is, okay, let's understand this. What is the engine, right? So a JavaScript engine, or whenever you are, by any chance, are you from computer science background?
Yes, sir.
Did you have compiler construction as one of your courses?
Yes, sir.
So what are the steps after reading the code?
Like tokenization and parsing.
Parsing or tokenize, which one first?
Parsing.
Right. So first you parse the code, then you tokenize it, right? So basically whatever this function is written, right? So what is going to happen is JavaScript is going to read, parsing means reading, Amit.
Yes, sir.
JavaScript is going to read all of this code, okay, as a string, right? Then this string is tokenized. What is tokenized? Basically where JavaScript, the language, is going to try to make sense of what is this keyword, console.log kya hai, right?
Yes.
And then what happens is it creates a tree, right?
Got it.
Right. And that's where these things, or the AST, as Javed has, I think, provided something related to that. So it creates a AST, abstract syntax tree, right? In which the rules of the language or the grammar of the language is applied. Once that happens, this code is converted into machine code, right? I mean, there are multiple steps in between that, but that will get too complex. But then it's converted into, in this case, it's converted into machine code, which the V8 engine or the JavaScript or the browser engine is able to understand, right? Once those machine instructions are ready with the browser is going to pass it to the downstream APIs of your CPU, right? As a process, that process is going to get executed, and then there will be callbacks going up, and that's how you get your result.
Good. Thank you.
So basically, you very cleverly asked us, how does the language, a programming language, work, right?
No, sir. My question on the first day, my question was this: what is JS engine? You said I will answer.
Do you have an answer now?
Yes, sir.
Okay. Sure. Hit me up if you want to know this in more detail. Would be happy to talk about it. But this is not.
You have not connected me on LinkedIn. I've asked many times.
I'll do that right now, Pradeep. Just put me a message on Slack after this. Cool.
Okay.
But I really like the curiosity. See, internally how it happens, guys, that is a very big story, right? So if we talk about the internals of V8, it's going to get very complex, right? I would love to probably talk about it sometime. So the V8 engine itself has 12 parts, right? Then these parts are basically working with each other to do different times, different things, right? So basically whatever happens between you writing the code, it getting translated and all these things happening is a big story, right? How the lift off compiler works, how the okay, anyway, I'm also getting astray. Event loop, back to event loop, right? So what is event loop? Event loop is basically this arrangement, guys, using which the call stack of JavaScript interacts with the web APIs. Web APIs basically, whenever they do their doing, they pass on the message to a messaging queue. Queue is FIFO, right? And whenever the JavaScript has time, whenever it's free, call stack is empty, it reads from the event loop and performs the same, right? So formally defining the event loop, the job of the event loop is to look into the call stack and determine if the call stack is empty or not. If the call stack is empty, it will read messages from the queue and execute any pending callbacks which were in this queue, right? Did you guys understand what I said? Shall I repeat myself again to formally define this if anyone wants? Repeat karun kya? Is that the yes for? Say repeat in that case. Okay, let me repeat this, guys. So the job of the event loop is to look continuously in the call stack and see if the call stack is empty or not. If the call stack of JS is empty, then it's going to look into the messaging queue. If the messaging queue has something, if it has a pending callback, right, which the browser might have returned, it's going to take that callback, push it to the top of the call stack and execute it. Understood now? Shubham, Mayank, Pankaj. Shubham bhi to haan bolo pehle. Okay. Okay. But building on top of this, guys, this is not just true for set timeout, right? So set timeout was only one example of a browser API, right? Like I mentioned in today's class, at the very beginning, there are other examples also, right? And I would like to take one of them. So when we say document dot, let's say, get element by ID and some ID, and then we say add event listener, click, and then the callback. So in this image example, how will that work? Upload and resize our JS work or browser work? I like that question, Amit, and I will take it after this. Okay, I'll revisit that example. Just hang on for some more time. Okay, do you see this document.get element by ID, this thing, right? So in this case, what happens is essentially this is also a browser API, right? And it should be, right? Why should JavaScript have any knowledge of HTML? The knowledge of HTML should reside with HTML, and the browser should allow us a functionality using which we can ask the browser about things happening on the HTML. Does that logically make sense? Right? In this case, whenever you are adding an event listener to this particular ID, what is going to happen is JavaScript is going to pass this callback again to the browser environment, right? And it's going to sit here waiting for this click to happen on this element, right? Because guys, understand it like this. What is JavaScript? JavaScript is a compute engine. It can only execute JavaScript code. It does not know when a click on a button is going to happen. That is not something which comes under the capability or purview of JavaScript, right? So this is handled by the browser. Now, what happens is whenever you click on that particular button with the ID as this guy, that thing, that event listener, which was sitting on the browser stack, right, is going to push this callback to the messaging queue, right? Because what has happened, a click has happened somewhere on the browser. Only the browser knows about it. Browser is trying to tell JavaScript about it. And believe it, the same concept is still going to get applied. What is the concept? Only when the call stack is free will it be able to run this callback. Whatever you want to do with click can only happen after you have done parsing or processing through that array. And this is all of the reason. Now, if we just scroll up, this is the reason that when this guy is happening, you will not be able to click the page. Why? Because you have clicked the page, the browser has heard you, it has pushed that event to messaging queue, but JavaScript will not be able to pull it out until and unless it has executed these tasks. Everyone clear so far? Right? Okay, so now we know what event loop is, what the browser's role is in by providing us APIs like set timeout, by providing us APIs like document, right? And yet another API, which I wanted to talk about because that one probably is the most important, right? It's called fetch, right? Javed has said it. It's called fetch, or the older variants of it are XML HTTP request, right? And what are these guys? So these are, so if this one is pretty much readable, right? So it means HTTP request. And what is HTTP? HTTP is a protocol which allows us to communicate with web servers, right? So how do you get data from a server, right? You require these two APIs for that, right? One is fetch, the other is XML HTTP request. Again, these are browser APIs which allow you to get data from a remote server. Remote server, okay? And let's understand what that even means. For example, you had opened google.com, right? And you started typing something on google.com, right? Let's say you were trying to search for, I don't know, cats, right? So does your browser already have that data? Or is it getting pulled from the Google server? Which one is it? Guys, which one is it? It's getting pulled, right? So somehow JavaScript has to do the job of making a request to a server, which definitely is not lying on your computer, getting data from it and doing something with that data. And what is that something? Basically doing DOM manipulations with that data. And why do I say DOM manipulations? Because the results that came in are being rendered as a list, right? In the browser. So in case of, for doing that, for getting that data, we use these two APIs, fetch and XML HTTP request. We are going to use them extensively very soon. But did you understand the use case for these APIs? How they work? We'll talk about it. Right? Okay, great. Before we move on to these APIs, because we need some more knowledge before we are able to, sort of move into them, right? There is one more thing which we need to learn, right? So how is asynchrony handled? Asynchrony is up until now, up until this point, was handled using callbacks, right? But browser uses cookies too. Vishal, cookies does not have anything to do with you getting the data from the internet, right? From a remote server. What is cookie? Cookie is basically a metadata or some small data that you exchange with the server. right? But it's not directly the data that you're pulling from the server. So whenever you're pulling a data, as a side effect of that, there is an exchange of cookies happening. What is a cookie? We will come to that later. Those of you who don't know, don't worry about it. That's a topic that is reserved for later. Right? Now we are in a position where we want to understand asynchrony better. Right? So we know this, and we know a lot of other things also. Right? So up until now, the only thing that you guys know about is whenever there is a set timeout, right? You have a callback which gets passed on to the messaging queue and is executed later, right? But there has to be a better way of dealing with this asynchrony, right? We can't just keep relying on these callbacks, right? So what are those better ways is what we are going to devote the next few minutes on. Or how much time, guys? How much time do we have? We are almost out of time. In that case, we might have to. Okay, let's just. Okay, that new concept which I was talking about, we'll cover that tomorrow. But today we will just spend some more time on these things, right? Yes, Javed. Even I'm thinking the same. It's a heavy concept. We'll start it with a fresh this thing. Yes, Shivam, I'm coming to that. Few more things we'll cover right now, just for practice of practicing these things, right? Okay, so one question for everyone. Let's just practice what we've learned, right? So let's say I do this. Which one do we see first, 1 or 2? 2 and 1. Wow. Who says, does anyone think 1 will come before? Nice. Very solid understanding. Hey, Amit says 1. Why, Amit? Explain yourself. Amit, explain yourself. Okay, and how does set timeout work? Please explain to us, Amit. It's not about time. Siddiq, it's not about time. No, it doesn't stop. Amit, were you even present in what we just talked about in the last 30 minutes? So what 0? See, okay, Amit, now I have to unmute you. Can you come on unmute, Amit? Sure, okay. Yes.
Yes, sir.
Batao, Amit, what do you think?
So my concern was, since it is to wait for 0 milliseconds, then
Okay.
why would it wait? It will execute that and then move to the next line.
But does it work like that?
Okay,
We know
understood. It
that-
will send it to the browser, and then browser will wait for 0 seconds. Then it will send it to message queue. Message queue will see whether the call stack is empty or not. And by the time these things would happen, console.log 2 would have got executed.
Amit, don't say that. See, so no. Let's say you were running these two things in one common function, right? Let's say I encapsulate them in some function called run, run, right?
Okay.
What happens? First, the browser sees set timeout, right? The second browser sees set timeout, it's going to move this guy here.
Okay.
Right? Although it's with 0, that's okay. This guy is also with 0. So immediately after 0 milliseconds elapse, it will move to the callback, this queue, right? But this guy was already pushed to the call stack, right?
Yes, yes.
Because set timeout does not get pushed to the call stack because it's a browser API, right? But this is a browser API, so it's already pushed here. And only after this guy is empty can JavaScript even read this guy.
Yes.
Right?
Yes.
Did you get it?
Yes,
so
yes,
guys,
yes.
one conclusion that all of us need to understand is This is not the time after which the callback is executed. This is the minimum possible time after which the callback can get executed. Are we clear?
Okay, understood.
Right? So if someone asks you, hey, is this an exact time after which this event will happen? That's the answer is no. Right?
Okay.
It's going to be anything more than this time. So this is the minimum possible time. So even if the call stack is perfectly empty, there is going to be some time, right? When this thing is going to happen, correct?
Okay, sir.
Okay.
Yes, sir.
Clear? Okay. Now, while we are at it, let's just quickly talk about set interval also, right? As is with this guy, as is with set timeout, same is the case with set interval also, which is a close cousin of this. Right? So set interval. What happens with set interval, guys? Instead of assigning one callback, set interval goes to the browser and it keeps sitting there, right? Just like this add event listener, it never goes away, right? So when you have applied a set interval, after each intervals, right? After let's say if you put a 2 here or a 3 here or 10 milliseconds or whatever, right? After those many milliseconds or that much time, it's going to continuously put data or put events in the callback queue or in the messaging queue, right? And again, the same cycle applies. Whenever JavaScript call stack is free, it's going to read the queue and execute those functions. Did you get it, everyone? How a set interval will internally function? Guys? Okay. The difference between set timeout and set interval is this, that set interval keeps executing the same task after the specified milliseconds, right? So what is going to happen with the case of set interval is it's going to sit in the browser, right? And whenever those many milliseconds elapse, it's going to push that data or push that event or push that callback in the callback queue or the messaging queue, right? And then the same cycle applies. Whenever JavaScript is free, the call stack is free, it's going to pick one of those messages or one of those events, and it's going to keep executing them after those many milliseconds, right? But please understand this, that during that time, right? So let's say we say set interval 100 milliseconds, right? During those 100, since the event only comes after 100 milliseconds and JavaScript tries to execute it whenever it's free, in those 100 milliseconds, JavaScript is free to do whatever it wants, right? This could be scrolling, this could be handling clicks and all of those things, right? So what the customer or you as a user is going to perceive that things are happening parallelly. Because what you will see, supposedly there is a clock running, right? There is a clock running on a website, which is a countdown timer, correct? So it's going all the way from 1000 to 1, right? And you have a click button in the middle, right? So each time you will still be able to click, right? Because it's not that the JavaScript thread is busy. It gets busy after every 100 milliseconds. And between that time, JavaScript has the time to execute your function, which is what? Which is, let's say, the click or anything else, right? Did everyone understand set interval? What I just said? So this will get continuously pushed to the empty queue until we stop by own or refresh it. Yes. And how do you stop it? Whenever you call set interval, right? Let me write it here. Whenever you call set interval, right? It returns a ID, right? So let my ID is equal to this, and you're going to write something here, right? Some callback, sometime, right? It's going to return this my ID to you. And what you can do is whenever you want to stop it, you can say clear interval, not clear timeout, and pass my ID to it. It will do the job of requesting the browser to clear this interval which was set. Same is the case with set timeout, but in set timeout case, it's slightly different. Please understand this. Set timeout also releases an ID, right? So let SID, I'm going to call it. stid for differentiating. You have stid, right? And let's say this guy was nothing but this guy was 10 seconds or simple 1 second only. And immediately in the next line, you said clear timeout. You say stid. What is going to happen is this guy will never execute, right? Because you had placed it to run after 1000 milliseconds, but you cleared it immediately, right? So these are important functions which are required to clean up intervals and which are required to sort of prevent these events from happening. These events, the callback events. Cool, guys. We are going to stop today here, and tomorrow we are going to learn how to deal with these events because they require for us to understand a new concept. Can we set timing for clear out as well? Clear out. What does that mean, Siddiq? Explain yourself. Sir, what is tokenizing, which you asked along with parsing? Okay. I was trying to make sense of that sentence. One second, Amit. Like after how many seconds it should automatically get cleared. You can't do that, Siddiq. So I mean, hypothetically assume that you are running a countdown timer, right? So in that case, you will use set interval, correct? Which will, after, let's say, every second, keep counting down on the clock, right? And what, let's say you want to say that, hey, after 30 minutes, just stop counting. In that case, what you can do is to your set timeout, you can pass the equivalent of 30 minutes in seconds here, in milliseconds here, right? And then you can say here, then you can call this guy here. So what that will do is that will clear your interval after 30 minutes. Got it? So after a certain time, you click this, clear this. So in this example, how will that work? Upload and resize our JS work or browser work? Okay. Resize is JS work, right? Upload is browser work, because dealing with network calls, as I talked here, that is getting data from a remote server or pushing data to a remote server are the work of a browser. But resizing is always the work of JavaScript. Right, Amit, about your yes, hang on, let's listen to RV. Sir, I am still not able to make out how functional instantiation take lots of memories, whereas shared method, because after running both of them side by side, I see no diff. So just clear that confusion. Can you clear my doubt in that case? How functional instantiation takes lots of memory, whereas shared method does not. See, RV, memory is not something that you will be able to gauge. I mean, impact on memory is not something that you will be able to gauge by creating, let's say, 5 instances or 10 instances. These things start to matter when, for example, in our example, we were talking about animal, right? So let's say you had to create 10,000 animals, for example. If you create 10,000 different instances of functions for them, right? Because each time you're using an anonymous function, a new instance will get created because there is no reference for it, right? So JavaScript has to create a new reference or a new instance each time, right? So for 10,000 elements, depending on the number of behaviors of those animals, you are going to create X into 10,000 number of functions, which definitely has a memory footprint, right? However, if you're able to reuse them by keeping them in one place, by maintaining references to it, which is what we did with the prototype. Now, whatever was failing on the whatever method was failing for lookup on one animal, those things were getting delegated to the prototype, right? And in the prototype, we have a fixed method right? Which is not getting redeclared again, because what is prototype? Prototype is a fixed object, correct? So each of the methods declared on the prototype are going to have fixed instances. So it's not like for every animal you're creating a new instance. You are going to reuse the existing instance. And that's how you save both of them taking default behavior. So we may use either of them just by, not really, right? So if you were creating new for each of them, hang on. So what is the discussion? Let's understand that first. Let's say you created function dog, right? And then there was a cat, right? And many things after that, right? There are two ways to solve this problem. One, on each cat, you define a eat method, right? So whenever you're calling this guy with new, there is going to be this dot eat, right? Which is going to be some function for this cat, right? And same example, rest or whatever, right? For a cat. Now, same things, let's say you create for this dog, right? Right? Each time you call this new cat, right? What are you creating? You're creating these two, this method also and this method also, correct? Right, Abhi? So it's going to, so let's just take this very simple example. When I say new cat and when I say new dog, how many total functions am I creating? Or for easy example, let's call it dog one and let's call it dog two. Let's not move into inheritance. You're creating 4 functions, right? However, if instead of doing this, you remove these guys from here, right? Later in here, you start saying dog one, right? Dot prototype, correct? Is basically equal to, I mean, you attach all of them in the dog prototype. So dog prototype dot eat and dog prototype dot rest, right? Again, move this out of the way, right? In this case, when you say new dog one or simple new dog, right? Let's say you call this one time, let B1, which is dog one, let B2, for example. In this case, right? How many functions were created each time I call these? What is the total number of functions? Which can you tell me here? No, there were 2 functions, right? One was eat, one was rest, correct? Right. And again, I'll just scale it to this example again. If I move this in here, right? And now no prototype. Now this dot eat, this dot rest, right? Now how many functions are going to get created, are we? How many functions will get created after these 3 lines execute? 6, right? Is this clear? And supposingly there were 10,000 such dogs. So how many functions would get created then? In this case, 2. In this case, 2 star 10 to the power 4, right? Or 10,000, 20,000. Yes or no, Arvi, Shivendra? So isn't there a clear memory saving when we are using this approach? Failed delegations, failed lookups on delegated to prototype. Arvi, question to you. So is your doubt clear now? Is the doubt clear? Or do you have any other question? Okay, let's take that specifically also 1093. Yes. What about this one? In this case, you have a shared animal methods, right? So whenever you were calling animal I each time, instead of creating a new method, right? So two options. Either you could have done this, what we had done, how it differs from functional instantiation. See, it differs great deal, right? Because here you are maintaining shared animal methods separately, right? And in this case, you are not maintaining those shared animal methods in the case below it. See, we discussed two versions of it. One is where we used object.create. So to delegate everything in here. Lastly, what we did here is we went one step ahead and we delegated everything on the prototype, right? So here there is no memory saving. The same memory saving that you get on shared animal methods, the same memory saving that you get on shared animal methods is the same memory saving that you get here. So this was not done for memory saving, correct? What was this done for? This was done for the capability of being able to apply functions or apply behaviors on the fly or dynamically, right? Because now I do not need to depend on another object, on a shared animal methods object. I have my prototype, and whenever I want to attach new behaviors to it, I simply have to say, and this I can see from anywhere, animal.prototype.new behavior and whatever, right? So this is ease of writing code. And the dynamism of attaching new methods, not memory saving. Memory saving is exactly identical here or when you had shared animal methods also. Of course, Pradeep, first you try to look for that property on the object itself. If it was created using object.create, then failed allocations happen on the parent object. I will push this code. Push the code, guys. Cool. Hope you guys had fun, enjoyed the session. You're welcome, Mayank. We will meet tomorrow then. Glad you liked it, Shubham. But object.create only to access, it can change the property for but object.create only to access, it can't change the property of permanent, right, sir? Of course, Arvi, it is, see, it is field, it is lookup on field delegations on the current object. Okay, Amit, your question, tokenizing and parsing. See, Amit, basically these are the steps which are required to be performed for a language, to be able to be executable, right? There are certain steps that you need to follow. So basically what you're writing as code, your computer, it only understands zeros and ones, right? So there is a process involved in converting that English, those syntaxes, those for loops, those for each and everything that you write to those zeros and ones, right? Or to the machine code, machine instructions, right? So for that, there is an entire process. So one part of this process is two parts of this process is what we talked about right now, parsing and tokenizing. There are many more parts to it, and different languages and different engines perform it differently. Of course, won't go into the depths of it in this course, but yeah. One question, from where and how did you learn things in such depth? It's everywhere, Amit. It's in all the books. Pick up any engineering book and start reading it, is my suggestion. In depth and JS. So like I told you guys in some of the beginning also, that I know the internals of that engine, right? right? So once you know the internals of the engine and how it's actually working, how it creates an object to machine instructions, how it converts a for loop to machine instructions, you can just make sense of everything. How, okay, I'm good with C++, so I have read the V8 engine. So once you start reading the V8 engine, the surface area is huge, by the way. It will take months. I wish I could have been from CS class because I believe in that. I'm not from CS also. So I don't see how the two are related. Avi, so really want to say that don't give yourself that excuse. Did you hear me, Avi, on that one? It's an important one. That's why I'm repeating it. So going too deep, Amit, that's a good thing, right? See, knowledge never hurts, Amit. Ignorance does. So knowing more is never a problem, right? Processing that is a problem. So your problem is not that I'm telling you more things. Your problem is you're not able to consume it at that rate, correct? And of course, the solution for that is revision. The solution for that is repetition, right? Gladly, we have all the code that we discuss in the class pushed, right? We also have these recorded lectures, right? So for me personally, you need to read them more and more, right? We need to revise them more and more. See, what we can offer here is concepts in their purest form, right? Once you do that, once you know the concept, once you've understood the concept, 50% or more of your work is done, Amit. So where most people struggle is that they are never able to get to the concept, right? Because if you read whatever we are learning here in the class, you can't read it from a book here. Even if you read 10 books, you will not get the same thing, right? So no, practice comes in later, Amit. First, understanding the concept, which you're already doing. Second is writing code. Writing more and more code and understanding what you're writing is what will take you a long way, right? Getting good with the code is what is required, guys. And this could be anyone, anywhere, right? So I started with C++.